Hello viewers, hope you all are well. I am Dr. R.S. Talegaonkar, Assistant Professor, Department of Chemistry from Mahatma Phule Art, Commerce and Sitaramji Chaudhary Science Mahavidyalaya, Varud. Today I am going to give you a lecture on volumetric analysis, which is a part of semester 3rd, comes under the BSc second year. So we will start with the content. It comes introduction, volumetric analysis, important terms, requirement of volumetric analysis, advantages of volumetric analysis, standard solution, primary standard substance, requirement of primary standard solution, terms to express concentration. Moreover, I am going to take here the classification of volumetric analysis also. So let's start with the introduction. All of you are very well known about the analytical chemistry. Analytical chemistry studies and uses instruments and methods used to separate, identify and quantify the matter. Analytical chemistry is the branch of chemistry which deals with the analysis of substance. It is mainly divided into two classes, that is qualitative analysis and quantitative analysis. Qualitative analysis is a part of chemistry that deals with figuring out the elements or ingredients of which a compound or mixture is made, and the quantitative analysis deals with the determination of amount or percentage of one or more constituent of a sample. Here are some examples of quantitative analysis, that is volumetric analysis, gravimetric analysis, polarimetry, fluorimetry, photometry, electrochemical and biological methods. Volumetric analysis. What comes under the volumetric analysis? It is a quantitative analysis, as you know, and it is one in which the volume of known concentration solution is required, and that will react with a solution of unknown concentration. Here are some benefits of volumetric analysis also. It is less laborious, more faster, more accurate method. And before going through the volumetric analysis, we should consider the important terms, that is titration. Titration is a process of determining the volume of the known concentration of solution required to react with a known volume of unknown strength solution. Then comes titrant and titrate. When we take a solution in a titration, while doing titration, that solution in a burette is called as the titrant, and the solution taken in a conical flask is called as a titrate. Then equivalence point or theoretical end point, the volume at which reaction actually completed. By addition of stoichiometric amount of titrant, it is known as the equivalence point or theoretical end point. Then what means the stoichiometry? It means the study of the quantitative relationship or ratios between two or more substances undertaking or undergoing a chemical reaction. Then indicator, a substance which is used for the visual detection of the completion of a particular reaction to determine the end point of a titration. Then comes end point, the volume at which the completion of the reaction is observed by using an indicator is called as the end point. It can be visualized or can be observed by the change of color or fluorescence or turbidity formation. While doing the volumetric analysis, there may comes the titrations error, and the difference between the equivalence point and the end point is known as the titration error. While doing the volumetric analysis, there are some need or there are some requirements of some conditions. What are they? The chemical reaction must be simple and take place quantitatively to form known product. The reaction shows some marked changes in some properties at equivalence point. It should be stoichiometric. It should be free from side reaction. It should be specific for the substances to be analyzed. The end point should be well defined and show visible changes by the use of the indicator, and the reaction should be relatively fast. Then there are some advantages of volumetric analysis over the other methods. What are these? These analysis requires simple apparatus that like burette, pipette, conical flask, beaker, and which are easily available. This analysis process does not involve laborious operation. It can be performed quickly and we get the results readily. This method is more precise and accurate, and depending upon the nature of the substance to be analyzed, different types of titrimetric methods can be used, which I am going to take after this. Then for this volumetric analysis we need a standard solution. Volumetric analysis depends on the use of at least one standard solution. And how it can be made? It can be made by dissolving and accurately weigh quantity of a highly pure substance. And the standard solution is a solution of known concentration. Then comes the primary standard substance. What is this primary standard substance? It is a substance which is used to prepare standard solution by direct weighing it. And the substance whose solution cannot be prepared by direct weighing, it is called as the secondary standard substance. There are some requirement of primary standard solution, and very few substances used as a primary standard substances and which satisfy the following conditions. What are these conditions? It should be available in highly pure state. Its composition or weight should not change during weighing in presence of air or during storage. The amount of impurities present should not exceed 0.01 to 0.02%. The substance should be readily soluble in a given solvent under the provided experimental conditions. It shows rapid reaction with the substance with which it is used stoichiometrically. It must possess the high molar mass to minimize weighing errors. Its solutions should be stable on keeping. There are some primary standards used in various kinds of titrations such as sodium carbonate, potassium dichromate, silver nitrate, EDTA, sodium chloride, zinc, and etc. While going thoroughly volumetric analysis, we should consider some terms which expresses the concentration. Which are these? First one is the molarity. It is denoted by capital M. The number of gram moles of the substance or solute dissolved in sufficient solvent to produce 1 dm cube of the solution is called as the molarity. And it can also be defined as the ratio of the weight of solute per dm cube to the molecular weight of the solute. Then comes normality. It is denoted by capital N. Normality is the number of gram equivalents of the substance dissolves in sufficient solvent to produce 1 dm cube of the solution. Then comes molality. It is denoted by small m. The number of moles of solute dissolved per kilogram of solvent is called as the molality. It can also be defined as the ratio of weight of solute per kilogram of solution to the molecular weight. Then comes mole fraction. It is denoted by capital X. Mole fraction of any component in a solution is the number of the component divided by the total number of moles making up a solution. Then comes percent composition. It may be of three types. It may be percent composition by weight. The percent composition by weight is the number of grams of solute present in 100 gram of solution. Percent composition by volume, V by V, it is the volume in which of which a solute present in 100 cc of solution. Then the percent composition by weight, W by V, it is the number of gram of solute present in 100 cc of solvent. Here is the classification of volumetric or titrimetric and methods. I am going to classify this in 5 types: acid base or neutralization titration. The reaction in which acid and base with the formation of salt and water is termed as the acid base or neutralization titration. Means when acid reacts with the base, there is a production of salt and water. Best example of this is the HCl plus NaOH, formation of the salt NaCl with the water. Then comes the redox titration. The titration in which one reactant is oxidized and the other is reduced is known as the redox titration. Here is the oxidizing agent and reducing agent must be present. The reaction of KMnO4 with FeSO4 gives you the K2SO4 and FeSO4 by 3 to MnSO4 plus H2O. In this oxidation reduction reaction, KMnO4 is acting as an oxidizing agent and FeSO4 is acting as a reducing agent. Then comes the precipitation titration. The precipitation titration involves the formation of an insoluble precipitate when the reactants are mixed together. Best example is AgNO3 plus NaCl forming AgCl plus NaNO3. Here the AgCl is a precipitate. Then comes complexometric titration, the titration in which stable, soluble and stoichiometric complex with the end point of a colored solution is formed is called as complexometric titration. The example is the reaction between zinc ions and the sodium salt of ethylene diamine tetraacetic acid means EDTA to forms the complex with zinc ion. Then comes the last point, that is diazotization titration. The diazotization titration is nothing but the conversion of the primary aromatic amine to a diazonium compound. In this method, the primary aromatic amine is reacted with the sodium nitrite to form a diazonium salt. Here is the example. Hope you like this lecture, and for the moreover, I am going to provide you a Google form for the deep knowledge of this lecture. Thank you.